Hello everyone. In this video, I am going to explain some previous questions which are asked in NEET and JEE Mains from electrophilic addition reaction and free radical addition reaction. Two mechanisms, two types of organic reactions completed. So we are in the topic types of organic reaction, in which addition reaction is a type of organic reaction. Addition reaction mainly three types: electrophilic addition reaction, free radical addition reaction, and nucleophilic addition reaction, in which two are completed in previous videos: electrophilic addition reaction and free radical addition reaction. In this video, I am going to give some previous questions on those types of organic reactions. Okay, right. So first one is this is propene unsymmetrical alkene addition of hydrogen chloride in presence of peroxide. Here we expect anti-Markovnikov product, because peroxide effect, Karash effect, what we expect? Anti-Markovnikov product. But anti-Markovnikov's rule is not determined here, not anti-Markovnikov's rule not applicable here, because peroxide effect not present on HCl. Peroxide effect only present on HBr, not present on HCl, not present on HI also. That's why, so on HCl there is no peroxide effect. That's why which product? Markovnikov product only, not anti-Markovnikov product. What is product we expect? Due to presence of peroxide, anti-Markovnikov product, but on HCl peroxide effect is not present, so product is what? Markovnikov's product. The spelling of Markovnikov's in some books, so most of the books Markovnikov's, in some books Markovnikov's also. Consider both. Right, that is question number 1. Question number 1 completed. Next question number 2 is addition of hydrogen bromide to propene takes place in presence of peroxide. Addition of hydrogen bromide to alkene in presence of peroxide, okay, takes place contrary to Markovnikov's rule. That means anti-Markovnikov's rule. Okay, statement is given. This is not question. Addition of hydrogen bromide to alkene in presence of peroxide takes place contrary to Markovnikov's rule. That is correct statement. In presence of peroxide, reaction takes place opposite to Markovnikov's rule. So this can be explained by mechanism involving. This can be in presence of peroxide. Which mechanism? Free radical mechanism. In presence of peroxide, free radical mechanism, anti-Markovnikov's rule. So in absence of peroxide, that is Markovnikov's rule. Which addition reaction? That is electrophilic addition reaction. Next, see this question. The major product P and Q in the following reaction respectively. These are options. First, see this question. So this is alkyne. On alkyne, this is what? Lindlar catalyst. Hydrogenation, two types. Hydrogenation is two types. Here hydrogen as well as hydrogen plus sodium in liquid ammonia. So I will write H2, sodium in liquid ammonia. Okay, so what is above one? Lindlar catalyst. So Lindlar catalyst and other catalyst, any catalytic hydrogenation, that is which addition? That is cis addition, syn addition. That above one is syn addition. So this is what? Birch reduction. Hydrogenation in presence of sodium in liquid ammonia is what? Birch reduction. Birch reduction is what? Trans addition, or it is also called as anti-addition. So here it is what? Syn addition. Here it is what? Anti-addition. Anti-addition gives trans product, syn addition gives cis product. So P is cis alkene, Alkyne upon hydrogenation give alkene. Alkene upon hydrogenation give alkane. Here alkyne to alkene. Here syn addition cisalkene, anti-addition transalkene. Cisalkene, transalkene. Cisalkene, transalkene. Which product is correct? So C. Option C is correct. Take this one. Right. See these questions. J mains question. 3-methyl-hextoluene on reaction with hydrogen bromide in presence of peroxide. So this is first hex 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3-methyl, third position methyl, and second position double bond. Second position is double bond. This is 3-methyl, 1, 2, 3, 4, 5, 6. Yes, hextoluene on reaction with HBr. On reaction with HBr in presence of peroxide. In presence of peroxide. So peroxide means what do we think? Anti-Markovnikov rule. Alkene, hydrogen bromide, peroxide. Anti-Markovnikov rule. Okay. So, peroxide. Anti-Markovnikov rule. Form addition product, the number of possible stereoisomers for A. So what is the addition product here? Anti-Markovnikov's rule means hydrogen added to double bonded carbon containing less number of hydrogen and bromine added here. That means what will be product? Here we get bromine and here hydrogen. No need to write hydrogen. Right. This one. Now this is what? This is what? A. For this, how many stereoisomers are present? How many isomers are present? So to calculate number of stereoisomers, first what we have to see? Number of chiral carbon. This is chiral carbon, methyl, this is some other group, bromine, and other is hydrogen. When carbon attached to 4 different groups, that is chiral carbon. This is chiral carbon, and this is also chiral because this is different from this one. These two different from this methyl, methyl different from hydrogen. How many chiral carbon? There are 2 chiral carbon. So number of stereoisomers is equal to number of stereoisomers. Number of stereoisomers is equal to, so how many? Geometrical isomerism not present because double bond is not there. So that is optical isomers 2 power n plus stereoisomers are 0. So what is n here? N is the number of chiral center. N is about what? Number of chiral center. So how many chiral centers here? 2 chiral center. Chiral centers are 2. Chiral carbons or chiral centers are how many? 2. So substitute here. 2 power 2, that is equal to 4. So what is our answer? 4. Number of stereoisomers possible for the product A are 4. Hope you understood. Next one, see this question. Major product of the following reaction is. In this reaction, what is major product? So what will be the major product? This is alkene addition of hydrogen chloride. Alkene addition of hydrogen chloride. So first, this is the reactant there, in which first addition of D plus instead of HCl here he has taken D, deuterium, hydrogen chloride, deuterium chloride. Okay, D plus addition takes place. D plus addition takes place according to Markovnikov's rule. So positive part attached to double bonded carbon containing more hydrogen. So that means this is that carbon containing double bonded carbon containing more hydrogen. That means H plus added here, both electrons shifted here, this attached to this one. Now here what will be the product? D. So D may be upside or downside, but in all the products D upside. D upside means take D upside. So what is other? What is here? 1, 2, 3 carbon mean other is hydrogen or not? Yes, other is hydrogen. Now by taking these pi electron, this carbon become positive. That is I am writing positive, and this is what? CH3. That is positive or not? Yes, this is positive. And what is the hybridization of that positive carbon? Hybridization of positive carbon is sp2. sp2 means planar. sp2 means planar. So on planar carbon, after addition of D plus, what is present? Cl minus. After addition of D plus, addition of Cl minus. So electrophile initiated, so electrophilic addition reaction. So this addition takes place. So here 4 different products are there. This is the carbon to which addition, 2 types of addition may takes place. So because sp2 carbon is what? Planar carbon for plane 2 sides. Chlorine attacking takes place from above or below. So that means 2 products we may expect. They are, so this is fixed H and D, and this is fixed D, H. Here for one time addition of hydrogen upside, for one time addition of chlorine downside. Here upside, here downside. 2 products are formed. Where is the product? DCl. So this is the product, okay. And DCH3, this is the product, okay. That means here 2 options are correct. Both options are correct. Option C and D are correct. Here see, D added to this carbon, that is wrong, because as per Markovnikov rule, positive part attached to double bonded carbon containing more hydrogen. Here hydrogens are not present, 0 hydrogen, here 1 hydrogen. That means positive part attached to double bonded carbon containing more hydrogen. That is Markovnikov's rule, hydrogen definitely added here. So D added to carbon that containing CH3 is wrong. D added to carbon containing CH3 wrong. D added to carbon containing CH3 wrong. Wrong. And between these two are correct options. Okay, take this one. Next, see these questions. The number of possible isomeric products formed. The number of possible isomeric products formed when 3-chloro-1-butene react with HCl through carbocation formation. First take 3-chloro-1-butene. So first but 1-butene. This is 1-butene. 3-chloro, third position chloro. 3-chloro-1-butene when treated with HCl. So what is the product? So first hydrogen added to double bonded carbon. Here how many double bonded carbon? Here double bonded carbons are 2. This one or this one. Which one contain more number of hydrogen? This one. Definitely positive part added to double bonded carbon containing more hydrogen. So why H plus added here? Because it become minus by taking this pi electron. That means this become positive. So this become positive here. Okay, here what is present? Chlorine. This is carbocation formation. Next addition of what? After addition of H plus from what? From HCl. H plus from HCl. Next what? Cl minus. Addition of Cl minus. In HCl, H plus, after addition of H plus, Cl minus addition. Cl minus addition takes place here. Cl minus addition takes place there. So 1, 2, 3, 4, here Cl, here Cl. The number of isomeric product. How many isomers are formed? Stereoisomers, total number of isomers. Okay. So here for this how many optical isomers are possible? So how many chirals enter? To say number of optical isomers, first verify for number of chiral center. How many chiral center? Number of chiral centers here are 2 chiral center. So here double bond is not there, geometrical isomerism 0. So stereoisomers is equal to what? Number of optical isomers, formula 2 power n plus number of, here 2 ends are same, number of geometrical isomers 0, because there is no what double bond. So that is 2 power 2, that is equal to 4. How many? 4 are possible. What is the answer? 4. I am using different colors to differentiate question and explanation options. Okay. So next question, the major product of the following reaction is. Major product of the following reaction, this is alkene, addition of 2 hydrogen bromides. Okay. So for that alkene, addition of hydrogen bromide. What is alkene? See there. So this is alkene, here methyl group. Okay. Here alkene and NO2. So whenever two groups are given, you must differentiate those groups. So this is what plus I group, and this is what minus I group or minus M group. Minus I and minus M effect are present. Minus M minus I, which is dominated minus M. So minus M or plus M, electron withdrawing, this is electron donating. Electron withdrawing, electron donating groups are there. Now addition of hydrogen bromide. If H plus added here, H plus from hydrogen bromide, where it is supposed to add. If hydrogen added here, this become positive. So hydrogen added here means pi electron taken away by this carbon and given to this one, then this carbon become positive. Okay. Next, this carbon become positive means bromine added here. Bromine will add there. Okay. So here, if hydrogen added here, this become positive. Okay, clear. That is stable one because the tertiary carbon. If hydrogen added here, this become positive, that is secondary carbon. Compared to here positive charge is more stable. That is my point. Next one, if hydrogen added here, this is what secondary carbon and this is also secondary carbon. Both are secondary carbon. If hydrogen added here, this become positive. Positive charge destabilized by minus M minus I groups. So here positive charge is less stable. Here positive charge is more stable. That's why hydrogen addition takes place here. So after that addition of Br minus, addition of 2 Br minus. Here 2H plus from 2H Br. How many H plus added? 2H plus added. After that addition of 2 Br minus. Addition of 2 Br minus. So what we get? Where is positive charge? Here is the positive charge. So here bromine is added. Already CH3 is there. Here NO2 group is there. Here what? Bromine is added. So which product is correct? Where is that option? Yes, option number 4. Option number 4 is correct. Okay. In this way, we do the problem. Okay. Take this one. Right. See this question. Increasing order of boiling points of major products ABC. First we have to write ABC and we have to order them in increasing order of boiling points. Okay. So what is the product A here? A is here double bonded carbon, addition of hydrogen to this carbon because that is containing 2 hydrogen. Here only 1 hydrogen. So hydrogen always added to, positive part always added to double bonded carbon containing more. So what is A? A is hydrogen added here means bromine added here. Bromine will add here. Hydrogen added here. Okay, no need to write hydrogen. Next B is what is B? Here hydrogen added to this carbon or this carbon to this carbon because that contain 2 hydrogen, this carbon containing no hydrogen. So definitely here what we get? Here hydrogen is added, here bromine. Next C. What is C? C is between these two, addition of hydrogen bromide to these. Addition of hydrogen added here, bromine added here. So that is what hydrogen added to one carbon, bromine added to another carbon. If hydrogen added here, bromine added here, that become like this. Okay. Now we have to arrange them in the increasing order of boiling point. Which one has higher boiling point? So see, what is this first? This is what secondary butyl bromide. Secondary butyl bromide. So this is what tertiary butyl bromide. Tertiary. And this is what so both are same. Here hydrogen added here. Yes, in presence of peroxide, I neglected that one. In presence of peroxide, opposite to anti-Markovnikov rule. That means to this carbon hydrogen is added, to this one bromine is added. That means what? So peroxide is there. This is what? Primary carbon. Primary. And this is what? Secondary butyl. All contain 4 carbon atom. 1 bromine. So molecular formula same. Boiling point mainly depends on molecular weight and intermolecular interactions. Okay. So all these are what? Isomers. They have same molecular formula, 4 carbons in each and 9 hydrogens in each and 1 bromine. Molecular weight is same. Intermolecular interaction. So as branches increases, surface area decreases, van der Waals forces decreases. Boiling point decreases. As branches increases, boiling point decreases. That means boiling point is directly proportional to van der Waals forces. Van der Waals forces. Not only van der Waals forces, intermolecular interaction. So here van der Waals forces are there. That's why I am writing van der Waals forces. Boiling point directly proportional to intermolecular interaction. Here what is intermolecular interaction possible? That is van der Waals force. Van der Waals force is directly proportional to van der Waals force directly proportional to surface area. Surface area inversely proportional to branches. That means as branches increases, surface area, I will write that to surface area, inversely proportional to branching. As branching increases, surface area decreases. That means as branching increases, surface area decreases, van der Waals forces decreases, boiling point decreases. As branching increases, boiling point decreases. Therefore, as branching increases, boiling point decreases. Surface area decreases, van der Waals force decreases, boiling point also decreases. That's why which one has highest branching? Highest branching is here. So B has lower boiling point. Here no branches, so A has higher boiling point. B has lower, A has higher. B has lower, A has higher. That means this is the correct option. Okay. So this is peroxide. So we have to identify that. Peroxide means CH3 here, C double bond O, okay, again O. So that is what 2 times. That is 2 times mean here no need to write O, given wrong in material. So here again what? O, C double bond O, CH3. O, C. This is peroxy bond. So this is peroxide. Peroxy bond is here or not? Yes, peroxy bond is there. That's why this is acetyl peroxide. Acetyl peroxide. Due to presence of peroxide, this reaction takes place according to anti-Markovnikov's rule. Markovnikov's rule. So here Markovnikov's rule is not present because this is symmetrical alkene. This is normal addition. No Markovnikov rule, anti-Markovnikov's rule. Boiling point directly proportional to van der Waals force inversely proportional to branching. On that we will answer. Okay, right, take this one. Next, see this question. Which of the following compound produce optical inactive compound, optical inactive compound. So if hydrogen upon hydrogenation means hydrogen added to here and here. If hydrogen added here and here, this carbon is optical active or not? Yes, optical active, because this is some propyl group, this is some isobutyl group. So this branch is not here, so this one different, this one after addition of hydrogens here, this is different, hydrogen different, methyl group different. Here in this condition optical active, by the addition of hydrogen also optical active, there is no change, it is optical active. Here if to this carbon here, if two hydrogens added here, this is different, these two are different, this is after addition of hydrogen, before addition of hydrogen, this is optical active. Here if hydrogen added here 1 2 3, just 1 2, this is ethyl group, and 1 2 3, this is propyl group. Before addition of hydrogen, after addition of hydrogen, this is optical active. So here hydrogen methyl, this is some isopropyl group, this is isopropenyl group, two are different. Now this is optical active, after addition of hydrogen. If hydrogen added here, then these two groups become same. That means after hydrogenation, which one become optical inactive? This one become optical inactive. See that. After addition of hydrogenation, a double bond disappears after addition of hydrogen. Here what is present? H, and here what is present? CH3. This is optical inactive. This one after addition of hydrogen, this become optical inactive, because these two are same or not? On this carbon these two are same, that's why this is optical inactive. So option B is correct answer, that upon hydrogenation become optical inactive. Take this one. Right, see this product of the following conversion is, this is some special case. In general what we do, addition of hydrogen bromide to alkene here or here, at anywhere takes place. So here between these two double bonded carbon, this if hydrogen added here, this become positive. So benzyl carbocation, carbon adjacent to benzene, so this positive charge is more stable when compared to this one. Of course this is secondary carbon, this is also secondary carbon, but this carbon is stabilized by resonance, this carbon is stabilized by inductive effect. Which one is more stable? This one is more stable. That's why hydrogen added, so compared to if hydrogen added here, this become positive, or what is other chance? Okay, if hydrogen added here, this become positive. Which is more stable? Here what is the effect here? Inductive effect, plus I effect. Here this is what? Resonance effect. So resonance stability greater than inductive effect stability. That's why this carbon become positive, and hydrogen added here, bromine added here, that is correct. Hydrogen added here, bromine added here. So on this one bromine here and here, between these two which one is correct? So hydrogen, bromine added here, bromine added here. Okay, that is correct product. Now between these two, B and C, which one is correct? So whenever you see the excess, okay, you have to think something is different, that yes, here different, that is what? Note, in excess of HBr, this become OH, Br added here, H added here. In this way here, right? So H plus added here, bromine added here, like this reaction takes place. That become OH. So OH means this is correct option. So in presence of hydrogen bromide, excess of hydrogen bromide, reaction takes place like this. Here addition of hydrogen bromide, here addition of hydrogen bromide, this become OH. That's why this is the correct product. Take this one. Let's see this question. Which of the following alkene will treated with HCl yield majorly anti-Markovnikov product? Which one gives anti-Markovnikov product? See here, anti-Markovnikov product mean in this one here, CF3 strong electron withdrawing group. Okay, here what is Markovnikov's rule? Markovnikov's rule means addition of HCl, in HCl H plus first. Addition of H plus from what? HCl. Okay, right here, if H added here, so that means this 2 electron taken away by this carbon giving to that, then here this carbon become positive and double bond become single bond, and this one become CH2 become CH3. This is highly unstable. Unstable because plus I groups destabilized by due to strong electron withdrawing group, CF3. Electron withdrawing groups destabilizes carbocation, and CF3 is very strong electron withdrawing group, is highly destabilizes. That's why this is unstable. So this will not form. Which will form? Addition takes place like this, H plus and same from HCl. It do not leads to that much of unstable. So reverse to Markovnikov's rule takes place in presence of strong electron withdrawing group. So this one is somewhat stable. Here also withdrawing group is there, but between this one carbon is there. So here this is more stable compared to this one is more stable. So that's why according to Markovnikov's rule, this one, but according to Markovnikov's rule, less stable intermediate. As per anti-Markovnikov's rule, more stable intermediate. Of course, Markovnikov's rule also based on stability of intermediate. That's why. So this is as per Markovnikov, this is as per anti-Markovnikov. This is as per Markovnikov's. This is what? Anti-Markovnikov's. So this is the correct. So here anti-Markovnikov's rule. Here this one, chlorine is what? So this is very strong minus I group. Here this is what? Minus I group, but weak minus I group. Of course, chlorine is plus M group, but for halogen, mesomeric effect less dominated, inductive effect dominated over here. So this one is what? Strong plus M group. Strong plus M group stabilizes carbocation. That means hydrogen added here, this become positive according to Markovnikov's rule. Here NH2 also what? Plus M group. Weak plus M group. So definitely plus M. So this is what? Plus M group. So plus M. Here hydrogen carbocation stable by plus M. Hydrogen added here, this become carbocation stabilized by plus M. Hydrogen added here, positive charge here, so somewhat unstable. Hydrogen added here, positive charge here, somewhat unstable. But this is highly unstable. That's why here reaction takes place according to anti-Markovnikov's rule. That's why this one answer, that leads to anti-Markovnikov product. Right, here onwards previous NEET question, not only NEET, All India pre-medical examination questions also taken, because for NEET there is one question paper for 1 year. That's why past 10-12 years questions I have taken from electrophilic addition and free radical addition topics. So this is reaction given, I think All India pre-medical examination 2008. So what is A predominantly? What is A predominantly? Electrophilic addition reaction. Okay, in electrophilic addition reaction, right here CH3 and CH3, what CH double bond CH2. Okay, electrophilic addition reaction begins with initiated by H plus electrophile, H plus from HBr, H plus from HBr. Okay, right here. So according to Markovnikov's rule, this become hydrogen added here, this become positive, that is stable. That's why that becomes CH3 here and CH3 here, and this carbon become positive, double bond become single bond, CH2 become CH3 after addition of H plus. Okay, here this is what secondary carbon. So here methyl group shift takes place 1 to first position to third position, not from first carbon to second carbon, first position to second position, methyl shift. What is this? I have explained in rearrangement of carbocation. This process is what? Rearrangement of carbocation. Then methyl group along with bond pair comes here. Methyl group along with bond pair shifted here, along with bond pair methyl group shifted here. So that it become CH3 here, CH carbon positive, and CH here what? CH3. What is used to transfer? Nothing. Hydrogen shift takes place here, not methyl group shift. So after methyl group shift, again that become secondary carbon or not. So not methyl group shift. First hydrogen has high shifting ability. Just like this. Not methyl group. That is what? Hydrogen shift, H minus shift, hydride ion shift takes place. So due to shift of that hydride ion shift takes place. By the methyl shift there is no benefit, because after methyl shift also that becomes secondary, that not takes place. Here that carbon become positive, methyl group there only, remains there only. Here hydrogen, by the transfer of hydrogen here, CH becomes CH2 and this is CH3. So what is benefit here? Yes, some less stable carbocation to more stable carbocation. This is what? Carbocation rearrangement. Carbocation rearrangement takes place. All rearrangement. Hydrogen bromide carbocation rearrangement is possible. Addition of hydrogen bromide. Okay, right. Now after carbocation rearrangement, Br minus addition takes place. So what will be product? Here bromine will added. Here CH3 and CH2. Here CH3. That means you must know carbocation rearrangement also. So if you don't know carbocation rearrangement 1 to transfer shift, you cannot answer correct. Okay, that's why in my video I have explained carbocation rearrangement at the topic reaction mechanism 1, carbocations topic, carbocation rearrangement, important one. So take this one. Which option correct? Which option correct? Yes, this one is correct. Right, next see these questions. So this question is NEET 2019 question. NEET 2019, above is All India pre-medical test 2009 question. Right. See here, benzene react with methyl chloride in presence of anhydrous Cl3. Benzene react with benzene. Yes, this is benzene. react with methyl chloride in presence of anhydrous AlCl3. So this is the not question, appropriate question, because this is electrophilic substitution reaction, not discussed yet. Okay, so don't take this one because this is not addition reaction until we discuss. Just I have taught only electrophilic addition, free radical addition, free radical substitution not yet discussed, so that is not correct. So see this, the most suitable reagent for the following conversion is, which one is the most suitable reagent? So here alkyne give cis means cis product. Cis product means which one gives cis product? Which one gives cis product? This is not reagent. Here ZnHCl, it reduces aldehydes only, and this is addition of water molecule. This reaction takes place in the form of addition of water molecule. This leads to formation of ketone. Addition of water molecule, ketone. Here this is what Birch reduction. Birch reduction is trans product. Alkyne with Birch reduction, anti-addition. Alkyne with anti-addition, trans product. Here this is what Lindlar catalyst. Alkyne, Lindlar catalyst is syn addition. Alkyne with syn addition, cis product. So this is correct. Okay. Here this reduces. Okay. Here reduces. Generally this is what general reduction, not stereospecific reduction. Here addition of water molecule HOH. OH undergo tautomerism, that gives ketone. So that is not ketone. These two are stereospecific. This is what Birch reduction, trans product, Lindlar catalyst, cis product. So this one is correct.